attention. Resuming innovation in the rendering industry, the use of rotational discs is a versatile tool that is employed in the rendering industry. And to understand how it works in the different phases of the process, we invite the engineer Jesús-Yataco with the following presentation. He's graduated in mechatronic engineering by the National University of Engineering in Peru. He has master's in project management by the University of ESAN and a certificate of DMP with the Project Management Institute. More than 12 years experience in the sector of transformation in meat and fish, beef and fish. He presently works in self-management for the Mexican market, having been previously project management and rendering projects and participating in the production of equipment in Latin American countries. He has participated in many congresses and meetings in the area of cattle products and rendering for pets. He will talk about many applications in rendering processes. Ladies and gentlemen, please a round of applause for Jesús-Yataco. Hello, good afternoon, everyone. As mentioned, I'm Jesús-Yataco. I represent the company Ostergaard. What I will talk about today is the application of rotational discs, many related to rendering plants. You know these rotational discs, and one of the few applications, let's say in Latin America, are the cooking machines. They can be used as cooking machines, replacing the continuous cookers, cooking machines. A brief introduction to Ostergaard. Ostergaard is a family company, has 7 years in the market. It's well positioned in the European and North American market. In Mexico, we are a relatively new brand in which the headquarters focused from this year onwards in a continuous presence to reach different clients in the Mexican market. We offer all machinery to produce meals from meat and fish. We can offer since complete plants, individual machinery to replace an old machine you can have in your plant, and also post-sales services like inspection of processes and spare parts. The Ostergaard team, the company is relatively new, 7 years. The technical team has over 30 years in the sector already. This would be our headquarters in Denmark, 17,000 square meters of offices and also workshops. We have workshops in, we have offices in Spain, Malaysia, Australia, United States, and Brazil. Now, the main theme, which would be the rotational disc. The rotational disc is pretty well known for drying food, but we could use it for many applications. The advantages of rotational discs, it has a very high transfer area in the space it can occupy inside the plant. The retention time will be controlled because of the advancement and retrieval flaps, and it has a trustworthy system for the expelling of the condensed matter of the equipment. The principle of working is pretty simple. We have the entry of materials on the upper part, the exit of product in the lower part, which will also allow, in comparison to a continuous cooking machine, the entry of vapor in one extreme, the condensed matter by engine in the other end will give us the energy for thermal transfer in the product. The main application, as I mentioned, for the rotational discs is as dryer, the most known one. We can process water byproducts, poultry. The raw material we can dry can be feathers, a mixture of blood, feathers, and insides, which will be a mixed product. And the application for this dryer, well, we look for a complete dryer, totally dry meal for mowing and packaging. The raw material that will be processed in this plant would be full whole fish or residues. The previous processes to the dryer would be pressing and centrifuge, and also the addition of concentrates that come from the evaporators. The difference of the bird theme in fishery, the rotational disc can be applied as full dryer and partial dryer. We'll see further on. Finally, the applications for the dryer would be the corn and wheat seeds, and we would dry the residues or solid residue of the distilleries. This would be in more detail the process of poultry drying. As first application, we have mixed meal, which would be feathers, blood, and insides. We do the cooking, hydrolysis, dry, and the rotational disc can do the full drying process and obtain the meal, which would be packed. Second would be feathers and blood. Same wise, the feathers can go through a hydrolysator or a batch cooker and then placed into the dryer after going through a coagulation phase. Third application, well, simply drying feathers. Same wise, being previously gone through the hydrolyzation process or through the batch cooker. And fish, as I mentioned, rotational disc can be applied for full or partial drying. Rotational disc will always be applied for the first drying phase. The materials coming in would be the pressing pie. We're talking about 42% humidity up to 50, depending on the raw material. We will have the decanter pie. We're talking about 50% humidity, and additionally the concentrate, which would be 60% humidity. This mix would provide 55% humidity that would come into the rotational disc dryer, so it passes on to other phases according to the size of the plant. Very large plants will have 3 drying phases, which would be rotational disc, rotational tube, and hot dryer. Mid-sized plants could have only 2, which would be rotational disc, and second phase could be a rotational tube or hot air dryer. That means the rotational disc would do a previous part of drying, which would do, we're talking about a 55 to 45% humidity, and the rest would be done by the other equipments. The advantage of the rotational disc is that there would be homogenization in the first phase of drying. Smaller fish plants only apply rotational disc. No problem in putting all the mix of raw materials, 55% humidity, and obtaining in the end 8% humidity. Now, this application that's not so well known at the Latin American level, which would be to use the rotational disc as a cooker. Materials that can be processed, poultry, insides and bone, and meat, same wise. And the difference between meat and poultry we can process without adding oil. Well, here are the applications: insides, bones for meat, and poultry, and this is the difference between recommendation and requirement. Why do we say that for poultry insides we can process without adding oil, but an addition of oil will enhance the thermal transmission, making the ability of cooking being better with the same transfer area of the equipment. sorry, I forgot to mention in the case of meat, we require a phase of mowing. We have large insides in cattle, and we need to reach a 30 millimeter dimension so cooking is proper and reaches the center of the product. In the case of poultry, for the process, it's not necessary. So, but I understand there are regulations that require the rendering plants to install previous mowing processes. If we compare the rotational discs with the continuous cookers or batch cookers, what we will have as part of the design is smaller revolutions in the equipment. What takes us to that? It's a better treatment of the matter. We avoid blending the product too much in the equipment, and we'll have less generation of fine product. We'll have better oil quality and better oil production corresponding to the design of the extractor, the dome form. Well, this is an image you can see in the rotational disc. It has an oval shape. This oval shape allows us to reduce points of matter accumulations in the corners of the dome and reduce the speed of the balls when the product is aspirated. This speed will be reduced, and then we have to drag less matter to the bowels treatment. Products like condensers and afterwards the older treatments. Another advantage is that the discharge is done by the lower part. If we compare it to a continuous cooker, the discharge is done in a high part. The lower part has this better use of the equipment. Let's talk about oil reduction, cost reduction. The rotational disc gives you the option. So in case of poultry, to avoid oil. With meat, you always recommend adding oil. The advantage of reducing oil will allow you better pressed product with less fat, less oil, and you have better pressing ability. And a meal with less fat. The options of rotor materials, what we refer is the versatility of the rotational disc for all materials it can be processed is so large that we provide the option of the clients to choose the materials for the rotor. Applications of fish, for example, don't need an inoxidable steel rotor, just need a carbon steel, very corrosive matters. Recommendation is working with stainless steel rotor that allows for two things: better lasting time of the equipment, and the option that when you have a requirement of a meal final product, all the materials inside the cooker will be in contact only with a stainless steel.
So I mentioned on the slide, this helps us also to reduce the speed of loss out of grass stators. You see the design to be more compact to the system and against a fire alarm. It's quite good for fishing. It's a flammable meal. The inner discharge is adjustable, allowing us to be proper to the size of the plant, also the deflection and windows for the equipment. This is an internal view of the equipment. You can see access to one piece. We have the discs parallel to one another, which we'll see in more detail later. We have the entry of vapor steam with a thermal transference, the condensate output, and also we have a tool called Fisher for to make sure that all the condensate generated in the rotor to be extracted. Part of the design of the rotor, this point that we can see are the advancement pellets. Beginning of the presentation, see the time of retention, could be adjusted or adapted. This advancement pallets or neutral pallets, they can be disassembled, meaning that during they get started or they're changed raw material. Simply, maintenance department can disassemble them, make a new adjustment of the pallets, and to begin to process it. So, one important point of the dryers of the discs are the design of the discs. The difference to the old ones, the old images that before we saw the triangular section. In this extreme, we see the current design. On the right side, the old design. For a comparison reason, much people in maintenance are accepting this new design, which are two walls, let's say left or right, that we can see here, seeing more details. And these walls will be in parallel, and combining them with the made with process one. The difference in the other one, it's a little bit of the inclination is a little bit exaggerated, but we have a triangular section forming the two walls. The disadvantage of this whole always the element that finally assured, we see that there's no deformation of the disc, high pressures of steam. One of the main points of these old designs, well, the difference in design that we see the diametral zone, the external part, far from the center, two internal ones. Uh, we see here metal plates, the volume containing vapor, and the second plate be welded to the extreme of the walls of the discs, functioning as a sacrifice. This allows us to, after been operating, been working this equipment for a couple of years, the maintenance area, you see that there's a wear and tear in this plate. Simply, it is conducted some sort of a, we cut the plate and we weld it, and a new one is put in place, avoiding any use or adjustment of material directly in the walls. In the old designs, we see that the walls overlapped on the end, generating some sort of, before the wear and tear of the material, we would lose one of the ends maintenance to bring new material because there was we lost the steel. It took a lot of time for this welding, especially having kept the plate over plate were heavier. This will reflect in downtime. It was reflected in increase of current consumption, less capacity for drying up. Finally, the option of having a versatility, the matter of the rotor discs, it is that the rotor have different thickness according to the different materials also. Stator, recommend this to be manufactured. Oh, that is very corrosive. Rotary discs will use 2 millimeters of stainless steel and 8 millimeters in the upper part. For the rotor, we have three options. The disc depends on the abrasivity. If the material is made of carbon, the thickness will depend on the corrosion. Finally, we have some images. This is in Dinamarca. You can see that we have basically rotary discs in series in fabrication. This is we made the discs, all of the welding